Yeah, okay, so again, key phrase, not allowed to use the phone with thermal line integrals. All right, so let's first understand what this path is, right? And t starts at 0, ends at pi, and so let's draw a picture. Let me come down here a little ways. Let's see here. I have, oh, this is an R2. Whoops. Okay. And all right, plug in t equals 0, and you get 1, comma 0. So, all right, great, 1, comma 0. So it starts there. Is that cool?
Do you get pi?
Oh, did I do it wrong?
Oh,
Hang
no,
on.
wait, no. Sorry.
Okay, yeah, no worries. So t equals 0, we get 1, 0. Yeah. All right, now let's see. So it ends then at when t is equal to pi, at which point those cancel. If t is pi, then I see cosine of pi is -1, so I have -1. And then, again, these cancel, and then I have, let's see, sine of pi is 0. Okay, so 0. Okay, so -1, 0. So it ends here. And in between, who knows? Right? All sorts of kind of weird. So there's our curve. Now, the problem says use path independence. It specifically tells us to use path independence. So I'm going to take them up on their advice and say, you know what, I don't like that path. I would much rather deal with that path that has the same start and same end. It's just easier to work with. Right? Okay, so goodbye to that other path. All right, and we're computing a line integral of the gradient. Well, let's see here. By the way, you'll notice that the gradient of this function is easy to write down. It's 2x comma 2y. Right? All right. And then let's see here. Let's parameterize this curve. This curve starts at 1, 0 and ends at -1, 0. And I can accomplish that by x of t equals, there's different ways you can think about this. You know, you could say 1, 0 plus t times -2, 0. That'd be pretty good. That's sort of like, you know, there's the difference vector. Right? Is that cool?
Yeah.
Right? Okay. All right. And so, in other words, 1 minus 2t comma 0. And let's brute force it, because we're not allowed to use the fundamental thermal line integrals. So 0 to pi. Oh, excuse me. No longer 0 to pi. We're going. T goes from 0 to 1 here. There's that parameterization. Integral from 0 to 1 then. Let's see here. F, well, our vector field is 2x, 2y. Dot x prime. X prime, by the way, easy to compute. That's just -2, 0. dt, so I have integral from 0 to 1 of -4. Oh, wait a second. Well, -4x, sure. But what is x? Let's see here. X is, I'll do this in blue. That is 1 minus 2t. Now it's single variable. Is that cool?
Yeah.
See how I did that?
Yeah.
So, yeah.
Okay.
Okay.